Right, so we're looking at esters today because we're finished with acids and we're finished with alcohols, right? Now, when you decide to react an alcohol with any anhydrous, so these are dry acids, right? Under the presence of sulfuric acid, which is a drying agent, you get an ester, which is an oily, sweet-smelling liquid, and water being formed. So the typical name for the forming of an ester is what we call esterification. So like you see in the little general equation, right? You would see that the arrow here is reversible because you could take your ester and water and break it back down to alcohol and acid. Or you could add your alcohol and your acid and you get your ester and your water. So for example, I have ethanoic acid and ethanol. With the concentrated sulfuric acid and heat, you get your ester, right? Now, if you look at something here, showing you something, right? To know, some of you will ask me, well, Miss, how you get that ester to form there? How you know the structure, right? You see, whatever your alcohol is and your acid, watch it, right? The H from the hydroxyl group will bond with the OH from the acid. No matter what you use, right? That is where the bonding will occur. And then this double bond will go on top here, as you see here, right? And this bond that attaching onto the carbon here will now attach onto the oxygen here. Are you all seeing that?
Yes.
All
Yes,
right.
miss.
We eliminate this to create the H2O, which is the water. All right. So when I eliminate the hydrogen from the hydroxyl group in the ethanol and the hydroxyl group from the ethanoic acid, the double bond for the oxygen on the acid goes on top the carbon there. This dash that you had added onto the hydroxyl group will now combine with the oxygen from the ethanol, right? And you have your ester being formed. H2O represents the two hydrogens that you took out and the oxygen, right? Now, they're typically the sweet-smelling oily liquids found in your fruits and your flowers, right? You know, in Portugal, when you take the rind and you squeeze it, right? Because some of used to do that nonsense when it was in primary school, right? The rind of the Portugal actually used to be kind of oily. When it is squeezed, you have an oily liquid come out, and then you smell the scent. That's actually an ester. Vegetable oils like your cooking oil, animal fat. Those are different long esters of long chain acids that are called glycerol, right? So the functional group for an ester is C double bond O, single O, or in some cases you might see a dash COO dash. You might see that like in a shortened structural formulae. Any questions there so far?
No, miss.
No, miss.
No, miss.
All right. So I want you to take a couple minutes and complete this, and then we're going to look at the names and the formulae of the different common esters that you All right, so we're moving on, right? So the names and the formulae of your esters. Now, usually it's the name of them is basically with the acid and the alcohol that is derived from. When you're writing the formula, the acid part must go first, and I'll show you the example, right? So let me zoom up into this one. This was the acid here. So you realize that the acid took the first part in the formula and then we put the alcohol over here. All right. So when you're writing the formula, the acid, right, orientation will take the first part of the name, and then the alcohol will take the second part of the formula. With the naming, it is very opposite. The alcohol will take the first part of the name, and then the acid will take the second part of the name. So going back over with that one more time. When writing the formula or drawing the formula of an ester, the acid takes the first part of the formula, and the alcohol takes the second part of the formula. When you are naming them, the alcohol takes the first part of the name, and that's how we end up with ethyl, and the acid takes the second part of the name. Anybody has any questions on that so far?
No, miss.
All right. So I have
Yes.
an example listed here, right? So I have in my example ethanoic acid, which is CH3COOH, adding on to propanol, which is C3H7OH. When added on, it gives you propyl or propyl, however you want to pronounce it, ethanoate. So the alcohol take the first part of the name, which is propyl, and the ethanoic acid takes the second part of the name. So the alcohol, if you're using methanol, it will be methyl. If you're using ethanol, it will be ethyl. If you're using propanol, it will be propyl, etc., etc. So the alcohol, instead of being anol, you change the ending to YL, and the acid, instead of being ethanoic acid, it will become ethanoate. So you add O8 to the acid part of it. If you're using, let me say, metanoic acid, it will become propyl metanoate. If you was using butanoic acid added on to propyl, the propanol, it would have been propyl butanoate. Understand? So the alcohol's name, the ending from anol will change to, you're putting in the YL, and the acid ending will become O8, right? Any questions there based on that?
No, miss.
No, miss.
So again, couple minutes, let's take this down. When you're finished, let me. All right, so we're gonna move on now to the other part of the topic for today, right? So I have a list here of the common esters that could come, right? So you have methanoic acid added on to ethanol to give you ethyl methanoate, butanoic acid added on to methanol to give you methyl butanoate, and propanoic acid added on to butanol to give you butyl propanoate. All right. Now, with regards to the laboratory preparation of ethyl ethanoate, this is how it goes, right? So you take your ethanol, you add it onto your dry acid with your concentrated sulfuric acid, you heat it under reflux. Reflux is where when the vapor is going up into a tube and it's coming back down, right? The mixture is then added to water. Because the fact that the ester is an oily liquid, it's going to float on the water, right? Because it doesn't dissolve, it's immiscible as we call it. And then when it's created over the water, you use a separating funnel, right? And you separate out the water from the oil, and you get your ester, your sweet smelling ester there. The reason why, and they will ask you this if they ever bring esters for exams, and they ever ask you, well, what was the purpose of the sulfuric acid? One, you need to catalyze the reaction for it to speed up and occur faster. And two, as I said, it's a drying agent. So it prevents the water from being formed, and it prevents any reversing. Remember, I showed you in the arrows when we were writing the chemical equations that these reactions are reversible reactions. So when the sulfuric acid is present, it makes sure that it doesn't convert back into the alcohol and the acid that it was originally, right? So this is a diagram of what the setup would look like. You have a round bottom flask over a Bunsen burner to give you heat. In the round bottom flask, you're gonna have a mixture of acid, and you're gonna have a mixture of the alcohol and the sulfuric acid. Like I said, it's heated on reflux. It goes up into this tube, right? The condenser is in reflux position so that when the oil is formed here, it goes back down, right, into the round bottom flask so that the oily liquid will settle on top of the water. Then you pour out your water and your oily mixture into your separating funnel, you separate it out. And that's the preparation of esters simplified, right? Anybody has any questions based on such?
No, miss.
No, miss.
No, miss.
All right. So Zoom time warning. Let's restart the meeting. Same ID, same password.